You gotta know a day. Today we're going to talk about friction, which is the force from two objects rubbing together. And sometimes in life you want a little more friction. Sometimes you want a little less friction. But either way, the equation for friction, or the friction force, is F of friction equals mu, that's what that little symbol is, which is the coefficient of friction times the normal force. Let's talk about coefficient of friction first. It's basically how rough a surface is. It's the two surfaces that are rubbing together. So in this picture, cat paw plus ice has a low coefficient of friction, or mu. If you have a smooth surface, you're going to have less friction. That's the mu part of the equation. If it's rough, it's going to be a much higher coefficient of friction. Talking about normal force, that's the other part of the equation. What is normal force? Well, we have the force of gravity on all objects. All objects with mass have the force of gravity. In this instance, we see it right here, pointing down. We also see this man, who's actually a hero of mine, showing the force of tension. That's any rope force. Well, in reaction to those, we have the normal force, which is the force from the ground. The fact that the sledder, is not going to the center of the earth, even though gravity's pulling him that way. The surface pulling up is that the surface pushing up is that normal force. And then also, there's that friction force. Remember, friction force equals mu times normal force. Well, the reason they're connected is that when you have a high normal force, you have the surfaces moving closer and closer together. So that friction force is going to be felt on a microscopic level more and more. That's why a normal force leads to a higher frictional force. And also, I want to remind you, frictional forces are always going to be opposite the movement. So he's pulling him on the sled to the right, so the friction must be to the left. Let's talk about friction and driving. So when we drive, the wheel spins around. Let's say it's spinning clockwise. Well, when it spins clockwise, it comes in contact with the road, and it exerts a force of the tire on the road. Well, because of Newton's third law, every action has an equal and opposite reaction, the road pushes back. And that push back is between two surfaces. It's a force of friction as well. I'm also going to say tire and car all have mass, so they're going to have a force of gravity. And also, the road is going to not only push forward because of the friction, but is also going to push up with another normal force. Remember, normal force, friction force are connected. Well, sometimes you want to stop or turn on a road, in which case you want friction as well. When you don't have friction, especially when it's raining, that is called hydroplaning, where essentially water, the hydro, is leading to a lower coefficient of friction, like these poor suckers here. Be real careful when you're driving and it's hydroplaning, because you want a much higher coefficient of friction. Actually, rubber on dry concrete is a very high coefficient of friction. But you get water between there, it goes down considerably. And that force of friction on the road is called traction, another word to know. There are two flavors of friction. There is kinetic friction and there's static friction. Static friction is when you're pulling on something or pushing on something, you're giving a force and it's not moving. The ground is pushing back. Well, once you get something moving, saying you're pushing a desk or something across the ground, you've overcome static friction, but there's still friction. It's not just all of a sudden skyrocketing across the ground. There's still friction pushing back. That's called kinetic friction. Kinetic means to move. And typically, in almost all cases, static friction is going to be bigger than kinetic friction. Think about how it's much harder to get something going than it is to keep it going. And there's also something called friction is also a non-conservative force. And a good way to think of that is if you take a spring and you stretch it out, you let it go, and it's going to, that force of the spring, the elastic force, is going to pull it back. It's going to be able to turn it all into kinetic energy, as long as it's just a good spring. But if you put a force on an object, like if you're sanding something, that's friction force. It's between two surfaces, and it really matters the path that you take. With a spring, you can go back and forth and back and forth and back and forth, and as long as you stretch it to the same amount, you're going to get the same amount of energy back out of it. With friction force, a non-conservative force where the energy is not conserved in a way that you can get it back out, that is the path matters. So every time you spin this around on the table, friction is going to dissipate some of that energy. Instead of it becoming a kinetic or movement energy, it's going to get dissipated as heat. Speaking of heat, friction turns energy into heat. If you want to experience this, just rub your hands together. You rub them together enough, they're going to get hotter and hotter and hotter because you have friction between your two hands, and that energy from movement, the force of friction is turning it into heat. We can employ that by lighting fires with friction, especially if you're really, really good at it. And you can even use heat in mechanical processes like this to weld things together. It's actually a really energetically safe way to weld. It's energetically safe. It's low carbon impact. It's great for the environment if you need to connect metal using a friction weld. Another thing to talk about, and a good thing that they really like to ask about, is lowering friction. You can lower friction by lowering that coefficient of friction. You can use lubricants, like Will Ferrell is right here. That would lower the coefficient of friction. And also ball bearings are in a lot of things which will lower friction as well. And if you are anything like me and you're getting really excited by all this friction talk, maybe you can become a tribologist, which studies friction. And there's lots and lots of uses of studying friction. But yep, it's called tribology. So that's friction.